Okay, back again with this cool little animation from the University of Colorado in Boulder, and I'll put the link down below so you can go to the website yourself and play around. Um, what this is showing is the relationship between heat and pressure, as well as the number of molecules within a container. So again, like the previous video, I can change the element from neon to argon to oxygen to molecules of water. And just because the water is in this kind of I forget, this crystalline shape, this definite structure, I'm going to switch over to maybe argon just because it's a single atom. And so right now it's in a solid state. As you can see, it's vibrating and it's in this certain structure. And what I can do here is take the pump and pump in some more atoms of argon, and it'll just kind of freeze right in with the other atoms. Okay, but we're really more interested in what will happen when we um, change pressure and heat to a gas. So we're going to heat up these atoms and it'll change from a liquid to a gas. And you can see as I heat that up and we turn it into a gas phase, you look over here at the pressure gauge and you can see how the pressure has been climbing. It has climbed from 0 to whatever, 12 atmospheres. And so if I heat it again, I'm going to give these atoms more energy. It'll have more kinetic energy. It's going to move more rapidly. And because it's going to move more rapidly, it's going to bang up against the sides of the container, and that will increase the pressure in that container. So if I give it more heat, all right, now it's heating up, and you can see the pressure gauge going up and up and up. Okay, and right now it's at the temperature has risen to 361 Kelvin, and I can do the opposite and cool it down, and the temperature inside the canister is going to reduce, the kinetic energy reduces, and thus the pressure reduces because those atoms aren't as excited and they're not moving as fast. Okay, and so again, I heat it up, and it's going to increase pressure because those atoms are really moving and banging up against the sides of that container. Now, what would you suppose would happen if I increase the number of atoms in the container? Well, let's pump a few more in there. And if you notice that pressure gauge, it's going to start to rise a little bit, right? Now it's at 31, 32. Pump on a little more. Okay, and so because we're adding more energy into that container, it's going to um, increase the pressure, just like putting more air inside of a balloon. All right. Now, the third option in this really cool animation here is this finger. What I can do is make the canister, the container, smaller. So when we reduce the volume of space that holds on to these atoms, then logically these atoms are going to bounce a lot more because it has a lot less room. They're going to bounce against each other more. They're going to bang against the container more. And so that's going to create more heat and also more pressure because it's moving and hitting the sides of the container so much faster. So I can increase pressure by reducing the volume. I can increase pressure by increasing the heat. Okay, and after a while, let's increase that pressure some. And you can see that pressure gauge really climb up, and then finally it can't hold that pressure any longer and it blows. All right, pretty cool stuff. All right, um, so that's it. It just wanted to show you the relationship between heat, pressure, and volume when it comes to a gas. And it all kind of ties in together with the energy given to a molecule, that when you give a molecule or an atom energy, it's going to move faster. And when you take the energy away, like I'm doing right now, I'm cooling it down. It takes away that kinetic energy, and you end up um, reducing it, and you end up turning it back into a solid. Okay, hope that answered a few questions and gave you a better understanding of phase change and the relationship of heat and volume and pressure. All right, thanks for watching.